while it can seem like the distant future, some of the operational concepts you saw in the video represent those currently in development. At Gavini, we're proud to be building sustainment software which will help power the next chapter of America's operational concepts. Good afternoon, everyone. I'm Amir Higazi, Gavini's Chief Strategy Officer, and it is my privilege to introduce our next panel, Precision Sustainment to Maximum Efficiency. From future capabilities to current sustainment challenges, recent conflicts around the globe have illuminated the numerous sustainment challenges the United States faces today. The scale of sustainment needs has proven to be larger than anticipated. Platform life cycles are extending, and platforms themselves are more distributed than ever. Gavini is proud to be at the forefront, helping drive sustainment missions that will be discussed today. We've gathered a distinguished group of leaders who are shaping the future of sustainment, from utilizing cutting-edge software to proactively sustain platforms and forces, to introducing new technologies that reduce demand for traditional resources. To hear about this important work, we will be speaking with Brigadier General Shane Upton, Director of U.S. Army Futures Command, Contested Logistics Cross-Functional Team, Captain Andrew Pecora, Commander of the Surface Forces Logistics Center, U.S. Coast Guard, Patrick N. Kelleher, Deputy Assistant Secretary of Defense for Materiel Readiness, Epirus CEO Andy Lowery, and our moderator, Colin Demarest, reporter and author of The Future of Defense at Axios. Please welcome our next panel.
What's up, everyone? Good afternoon. I'm Colin Demarest, the author of Axios Future of Defense. Y'all should sign up, but you aren't here to hear that. You're obviously here for this killer crew I have on stage alongside of me. I'm going to skip the titles, names, accolades. Y'all can Google them, and y'all are pretty well-known people in the first place. So if we want to jump into questions from the go, sounds good? Awesome. Mr. Lowery. Epirus makes directed energy weapons, which require precious parts, materials, et cetera. What are some of those supply chain choke points you see in your world that might be overlooked by a more general audience? And what can be done to fix those?
Okay. Yeah, there's a lot of news out there today about gallium. A lot of Chinese kind of bulk of gallium comes out of China. The mining, it's a process that is done when they mine aluminum. And gallium, they're worried, is a precious metal, rare metal that will be kind of taken by China and not exported. But there's a lot of misinformation about that out there. Most of the gallium that is used in high-powered semiconductors is actually sourced out of Japan. Japan is the #1 recycler of gallium, and so as such, they produce a pretty good market. Some of the bigger applications for gallium that have much more volume and stuff may have some impact, but in general, the stuff we do is very safe and, from known sources all the way up to the actual material. And I could talk more about that. I could go on and on about that. But I think a more important thing to kind of address is when you look at some of these machines, and we've seen a lot of talk about it through the replicator program and other things, that we just don't have scale. And in my particular situation, I'm not like all these hundreds of drones and thousands of drones. I build these big directed energy weapon systems. But those weapon systems, if you double click on them, have tons and tons of parts. So give you an example, if we were to receive an order for 100 directed energy Leonidas systems, that would then cause us on supply chain to need to order around 35,000 high-powered amplifiers, these very, very unique gallium nitride infused high-powered amplifiers. And so when I look at the market, we had maybe that capability back in the early 2000s with the base stations and the infrastructure and the cellular markets going crazy. But these days, you can hardly find a company that has experience with this kind of power and these kind of frequencies at this sort of volume. And so it pushes me as the integrator to say, well, where do I need to expand a little bit in my supply chain and actually maybe take it over. You know, maybe use some of my proceeds from investors and stuff to build a high-powered amplifier factory, sort of like Anduril's building the rocket factory.
Are you going to do that?
Not a rocket factory.
An HPA factory.
Oh, yeah, maybe a high-powered amplifier factory. I'm certainly looking into it. I've got a trade study going on right now, but that is an option. That is a definite option.
Awesome. Mr. Kelleher, years ago you oversaw the production and distribution of COVID-19 supplies, a mammoth task, a very grave task, and that involved forecasting and logistics to satisfy it. What is the DoD doing now to more accurately predict where things need to go, and then also getting it to where it needs to go?
Yeah, that's a good question. I mean, you know, that was certainly an interesting time. You know, my job, distribute vaccine therapeutics, test kits, and masks to the American people, and frankly, what they did with them after that wasn't my responsibility. So it was kind of an interesting dynamic. But that was really where I learned the power of leveraging data to be predictive. You know, the team the Warp Speed team did a phenomenal job connecting 200 some different systems at the federal, state, and local level, incorporating commercial data feeds, input from commercial manufacturing, and it really demonstrated what you can do when you can leverage data. I mean, at any given time, we knew exactly, you know, how many vials of vaccine were at 3rd and Main, any state in the country. How many doses did they administer, you know, yesterday? How many doses did they administer, you know, yesterday afternoon? So it really demonstrated what is in the realm of possibility right now today, given the application of the right tools. And I know you all have heard a lot about data already today, and I will tell you that, you know, we are building we have a very good data foundation that we are in the process of, frankly, I think nearing completion, at least in terms of near real-time visibility of global inventory of the department, of the global posture of the department's inventory, near real time. You know, and once we can start to harness that, you know, we'll have some very powerful insights. At the same time, you know, when you talk about readiness, we are leveraging automated reporting from each of the services in terms of what their operational availability and material availability, you know, real-time, near real-time statistics are. And so I think, you know, where we are sort of in our data journey is developing the tools, really capitalizing on the commercial tools, frankly, that are out there to enable us to do this better. My perspective is, you know, there are plenty of commercial companies that have literally invested billions of dollars in predictive and analytic software, and we should be leveraging that and not trying to invent it on our own. Because, you know, despite the title of the panel where we talk about efficiency, I think, frankly, it's all about effectiveness and changing the paradigm in the department to think about being effective. Being effective is expensive, but being effective is what is required to win, to fight and win. And so we just need to understand that to leverage the data, we have to make investments in, frankly, expensive tools, but that is what is required to be effective and to be able to leverage the data that we have to do a better job predicting, both in terms of condition of vehicles, when you talk about predictive maintenance or conditions-based maintenance, as well as predicting demand, consumption-based demand, whether that be fuel, munitions, or spare parts. And so I think we are on the cusp of really bringing to bear some powerful tools that, you know, that the network across the department is in various stages of developing. And I think we're, frankly, nearing the point of singularity in the department where we're able to really leverage the power of data. I mean, clearly work to be done. And as you heard, I mean, Army Materiel Command and you know, organizations like DLA certainly leading the effort in developing the data foundation along with the Joint Staff and leveraging commercial tools. But I think I am optimistic in this aspect of developing logistics, the logistics capability necessary to fight and win.
So, Captain Pecora, when it comes to maintenance, sustainment at all, what's something the Navy, Marine Corps, or other services can learn from the Coast Guard?
Sure. We're a small service, but we have unique authorities that allow us to operate a little bit differently than our DoD partners. For instance, if you look at the countries around the world, their navies are built more like the Coast Guard. And when we sail overseas, and we're operating in places like Bahrain and Oceania and in the South China Sea, and we're really good at building partner capacity with those foreign nations. You'd much rather see a white ship with an orange stripe sailing at you than a gray ship with big guns pointing at you, right? So we are a good soft instrument of national power. And I'll tie this to data in a second, but those partner nations we work with through foreign military sales, we're providing them decommissioned Coast Guard cutters, and it's helping provide some interoperability with those foreign partners that we're building relationships around the world, whether it's Oceania or in Africa or in the Caribbean nations. And I've had the honor of hosting many of those folks and sharing lessons learned about data and data management that helps sustain those older ships, whether it's parts or inventory or failure rates or operational availability. So we're giving them lessons learned. Now, could we do it better? Absolutely. We're not far away from, like Tara said, we kind of are managing by spreadsheets. We're kind of like one level above that, and we need to do a better job, but we have shared a lot of that data and data management and processes with those foreign partners to help them maintain their assets. Those relationships, I think, is something that the Coast Guard excels at.
And General Upton, the Contested Logistics CFT was established in 2023. What's the single most consequential finding or result thus far, and how has that been applied to the Army more broadly?
I'd say as my boss said earlier, General Rainey, as an intellectually curious organization that's brand new, 2 years into DoD speak is very new. Boiling it down to one, but tying it to data. I would say using data and the need for the Army and the Joint Force to use data in kind of 4 to 5 imperatives. One, using our data to help us globally posture better, make better decisions of where we posture our key assets for readiness, things like fuel, critical ammunition, especially things like precision ammunition. Because the magazine depth of those high-end rounds, like a hypersonic or something, are not going to be in large stock. They take time to manufacture in that piece, so that global posture piece. I'd say the next piece is looking at availability. So using data in the sustainment construct to really be effective, any of us that are logisticians or operate in a supply chain have to know where an asset is available in multiple positions. So those ties those two, because of that asset availability, then I can be much more effective to what we're there for, that young man or woman that needs it at point of need, when I know maybe it's not going to come from the United States, but it may be closer to theater, or it's a commercial source that an OEM has there, but seeing that data real-time availability. The next thing I think is using data then to make decisions faster. I would tell you just in my experience, and it's absolutely why we've got to focus, and we are, as a #1 priority in the Army on C2. But the C2 piece of that is the logisticians and the intel community that feed that command and control tool. We have spent a lot of our intellectual power over the years with Excel and even more rudimentary tools than that. I'd say 80% of our time in the log world, we're thinking about how we inform commanders, or if we had something at a data that would function, quite frankly, at machine speed or even eventually at AI speed, then that experience of the human then can come to bear on kind of more the art of that. That's something we've really seen. And that comes down to also kind of necking down, what data do we really use to make a decision? There was a great comment by one of the previous panels of, we're data rich, information poor, but there's a lot of efforts being led by Futures Command in the C2 space, and absolutely also in the other warfighting systems of, do we really need all the data? There are certain pieces of data that we use absolutely empirically every day to make critical decisions. There's a lot of data, though, that flows in that may be not needed. And then you get into points of effectiveness of necking down and really seeing that from commanders at echelon. I'd say that's kind of in the data space, those are kind of the imperative things we're really learning right now. And then how to apply those and then move fast and get them into the hands of our formations.
Awesome. I'd like to open up the conversation to more of a group talk here. Captain Pecora, you and I have talked about this prior, but the volume of systems, platforms, trackers, logs, databases, I think you said you use 12. Hopefully I got that number right. How chaotic is it keeping track across all these databases, and how can that be simplified?
Yeah, that feeds into one of my biggest challenges. We do have 12 disparate IT tools, one tracking configuration, parts, finance, you name it, contract modifications. And all those systems don't necessarily talk to one another. And so I have some really sharp folks, we call them deck plate level developers, who've built tools on their own time to allow that data to be integrated and synthesized so we can make smarter decisions. But it's like linear algebra. I need to take two metrics and see some trend analysis so I can make a risk-based decision in a limited resource environment. I need more powerful tools to be able to integrate that data so people aren't spending hundreds of man-hours trying to get me, the boss, a decision. I need to be playing in multivariable calculus, not linear algebra.
Mr. Kelleher or General Upton, any thoughts?
Yeah, I think what you highlight is, frankly, one of the hidden costs. We say, buying software X is going to be really, really expensive, but the substitute for that is an awful lot of man hours. That's a hidden cost that isn't necessarily exposed, but results in reduced productivity, if you will. Whereas on the front end, you could achieve better warfighting results, arguably, better readiness. Were you to make the front end investment, enduring investment, frankly, in software that does that which your Coast Guardmen do now, they can be focused on other things. And I think, frankly, that's where we need to go. As I said, we're never going to have a universal system. We're never going to have everything perfectly interoperable. But the degree to which we can leverage data from a common platform like Advana and simply build application layers on top of that pulls the data that we need, which is, I think, frankly, the direction that we are going. But again, it costs money. And, logistics applications, logistics IT, logistics command and control doesn't always necessarily compete well. Even though lethality starts with logistics and our ability to fight and win is predicated on logistics, it still does not, we have a tough time competing because it doesn't go boom.
Andy, a lot of what we're talking about here in the real world looks like convoys, warehouses, supply lines, a lot of things on the move, a lot of things that are fixed as well. How do you go about defending such vital resources on a battlefield, especially something that looks like Russia, Ukraine, for example?
Yeah, I'm kind of a simple guy, so I think three things here we're talking about today, and we didn't get to the third one yet. The first one is, manufacturing. And my simple way of figuring that is we got to get better at driving standards. There's a problem with the military having no definite customer, but then saying we need capacity for 100,000 rockets a year or whatever, and not sure you're going to be the come, so there's not a maybe commercial dual use for rockets. So the manufacturing needs to drive to standards. I think that's what Replicator tried to kind of do. But I think it needed to do a better job at developing military standards much more rapidly and allow a bunch of different startups or a bunch of different companies like Raytheon's and startups, everyone, to participate in a kind of a common framework. So that's how I think I would step one on the manufacturing side. And then the second step we said is data. We talked a lot about data being a mess, a complete mess in the DoD or whatever. And I think leaning into commercial companies like Amazon or Palantir, kind of an older brother to Epirus is Palantir, leaning into companies like that and allowing them to kind of do what the commercial companies have learned to do over the years. But it's going to require a lot of sharing and security and all these things that are tough to get around. Now the last line is like, how do you get the stuff to the war fighters? How do you get them out into the field? And we have a problem where we just can't penetrate deeply, in a maneuvering force, or we hear a lot about the wide-body aircrafts not being able to get in deep enough into contested airspace. Well, directed energy is a really, I think, interesting type of system or type of technology, type of physics that can get out in front of the line and put these fields of energy up. that just deny almost any kinetic type system that has some sort of guidance at some range. Now, the range could be too short still today, but that doesn't mean it can't grow bigger and bigger and bigger. And then as we put things on the bottom of these systems, like robot vehicles, like GD's T-Rex, we put a GD T-Rex on the bottom of a Leonidas, and you have a robotic Leo that can push out in front of troops. I heard General Rainey talking, we don't have enough troops. Well, I just need one young man or lady in a container with an Xbox controller, and now I have 5 or 6 robot Leos she or he is controlling out in order to clear up lanes in order to do it. I remember when I built the next generation jammer at Raytheon, you know, the ConOps for that was to drive a hole, right? Get a hole like a tackle and a guard in a football line, make a hole so the running back can run on through. So you hit this big, powerful RF energy, a one-to-many system, a system that hits all kinds of targets at the same time, the next generation jammer, and opens up a hole, like turns the lights out and allows the F-18s to fly in and very strategically drop their bombs, boom, boom, boom. This is the same idea with Leonidas, the same exact idea. The reason why I'm a CEO of this company, I'm building next generation jammer now for Army. That's basically what I'm doing, but it's jamming a little different. It does a little different technology in order to do it, but nevertheless, the same idea with movement formations and whatnot. You run these guys out in front to clear a lane, and then you bring your troops on in. That could be done in the air, that could be done on the ground, that could be done in space. I don't know if it can be done underwater. I don't know if I could get microwaves to work in these frequencies underwater, but in those other places, it'll all work.
I want to pull on that
please.
thread real quick. So kind of as a lesson observed and as we talked in the previous question, but to your point, he makes a great point about the distribution, that last piece you mentioned about how you get there. We're seeing a lot with uncrewed distribution and supply systems in 3 or 4 domains. So traditionally, we've looked for a few years on robotic ground-based systems to resupply, to tactical point of need, to an early formation. Now it's this interlocking of air systems that are, I think they might have showed a video before this that showed some of that, and even to our maritime systems, not necessarily underwater, but on surface, to do distribution networks that are uncrewed or paired with crewed systems. So one, you diversify that network. They're also at the edge to the effectiveness piece, and also to the adversary in a threat-formed environment. Now you've got multiple assets coming at you versus the big gray ship or the one that's white and painted orange, in a dispersed manner, kind of to offset that and be effective. What we are rapidly seeing as we look at things like directed energy, the rates of fire for even precision-guided or even just not precision munitions, is it's so rapid, and if you disperse, like we've talked in previous panels, how to do that continuously, we're going to have to start taking advantage. And to the group out there of uncrewed systems paired with crewed, just to get that volume. It's almost like a line of communication, another acronym, LOCK, that we just would keep constantly moving. And if it's not manned, then you're really just maintaining that system and keeping those key commodities moving, whether it's a commodity or if it's something to build material readiness. But him talking about the distribution, we're learning a lot about that right now, and quite frankly, to the point of you all in industry, how far you're already moving into that space.
Yeah, I think there will be I call it centaur warfare, or man not in the loop, but on the loop, where there's going to be a period of war, and eventually it'll probably get more and more automated and automated. But there will be a period of time where you have a man on the loop, and you say, let me make the strategic calls, let me make the strategic decisions, but the computer tells you, analyze these 1,000 drones coming in this way and that, and figures it up and says, this is the best way to take on those kinds of, this kind of a war scene or whatever. And then do you say yes? It's not, again, going back to next generation jammer, it's what they're doing today. The NGJ will give you 10 targets, I can do it, and the EWO or whatever will say, okay, prioritize that as one and then go. So you get like a quality check or a safety check or whatever you want to call it, strategic check, I guess, like in the centaur analogy, like the human end, and then you let the horse end, just run it. And I think that'll be warfare for the foreseeable future, maybe decade, maybe 2 decades, as it becomes more and more automated. And But we do have this new age, right? We're in an age, I said, look, we're doing guerrilla warfare. This is guerrilla warfare. But it's guerrilla warfare of machines, not of people. The people are kind of the next wave, if you will, in the warfare we see in Ukraine and Israel and others. It's guerrilla warfare. And we need to get better at that as a nation, because we only did guerrilla warfare really well once. That was our first one, our Revolutionary War. So since then, we haven't been the best of countries, I think, in adapting and all these different guerrilla wars that we get involved with. But that's what's before us now.
Mr. Kelleher, I want to turn to you regarding predictive maintenance. It sounds all well and good. You know, software predicts something will break in X days, send the part now and get ahead of the problem. Excuse me. But what's it really like on the ground? It can't be that easy, can it?
You know, I mean, clearly it's something we need to do, and you know, and we can maybe just to clarify at least how I think about predictive versus conditions. You know, predictive maintenance in my mind, and I know these aren't the doctoral definitions, but fix it when you know it's going to break, but before it has broken. And then you have conditions-based maintenance, which is fix it, don't fix it unless it needs to be fixed. Don't do any maintenance unless the conditions warrant it. And both of those are obviously key capabilities. And I think we have, frankly, I think we have the data foundation to build the type of algorithms that we need to be predictive. And some of the services are frankly doing a fairly good job at this already. The Air Force in particular, developing the ability to identify parts on aircraft that are going to fail, in the next XYZ timeframe. And then you can, offset the detrimental effects, battlefield effects of having to fix it when you weren't planning on fixing it, but where, instead you can plan to fix it when it has least effect, and you can, plan to coordinate the parts. But I think that sort of from both perspectives, that sort of predictive ability, coupled with better demand forecasting, necessitates, in my mind, or enables, if you will, greater depth of inventory that is postured in a more distributed fashion across a particular theater. Because the adversary will be able to challenge and target locations where we have resources, we will have to distribute more. And if we want to be effective in leveraging our ability to be predictive, we have to have a greater depth of inventory that is going to be positioned closer to where those things are going to break. And that can't be coming from CONUS, because we don't have the distribution resources that are going to enable us to close, even any of the tactical mile, let alone the last tactical mile. So better demand planning gives you the ability to build depth in inventory that will, which is not cheap by any stretch of the imagination. And the enterprise, the department, for all the right reasons, is still oriented on efficiency, and which does not necessarily enable us to buy inventory that we won't necessarily use. So we have to, what I say, make investments in informed inefficiency, and hopefully, frankly, we never use it. It sits over there in a corner, we never have to tap into it. But being predictive enables us to better position inventory where we need it, leveraging autonomous distribution systems so that we can not have to, so we really offset the disadvantage the disadvantage that we will face in future wars of our ability to leverage physical mass. We have to offset the lack of physical mass with data, visibility, and autonomous systems capitalizing on an ability, to be predictive, which frankly, we're not that far away. So,
what do you think about adjusting operation availability? Taking a look at, we're always 99, 99, 99 in this country, and that drives a lot of supply chain.
It does. I think that's a great point. We have to make prioritization decisions about the weapon systems that are going to be most relevant in our next fight. And those are not necessarily the weapon systems that were most relevant in our last fight, because we cannot afford to maintain any degree of readiness, high degree of readiness, on all systems, not affordable. And so one of the things that we are going to work with the services to do a better job with is understanding and really codifying in a formal way priority weapon systems. And that way we can focus our analytics, we can focus our data, we can focus our forecasting, we can focus our resources on maintaining a higher degree of readiness for those smaller subset of priority systems that each of the services, and it's going to be up to them to decide in conjunction with combatant commands and the joint staff, and then tell us, we think these are important, okay. Then we can, at the OSD level, integrate those weapon systems into a more holistic approach for readiness.
Captain Pecora, I'm going to turn to you. When you think about contested logistics, I think what comes to mind is getting shot at, getting bombed, getting jammed, et cetera. But weather also plays a role in here, especially as it gets more extreme because of climate change. There's lots of talk about the Arctic, which brings up a whole other set of challenges. How's the Coast Guard thinking about contested logistics in this weather, climate kind of aspect?
Yeah, so I would really reframe it as maybe austere logistics and austere environment. We're not necessarily right now dealing with the enemy trying to interfere with our logistics. Now that may happen. There's a lot of theories out there that the first shots with a war with China might not be kinetic. It could be a cyber attack, and it could be a cyber attack on our logistics data systems. If we don't know what we have and where we have it, that's a problem. But back to the austere environment. The Coast Guard does a really good job operating in the Arctic and in the Antarctic. We have cutters that go up there once a year to do very important missions. We actually call them no-fail missions. They are operating by themselves. So our logistics tools allow us to run all sorts of algorithms to figure out, what are those high failure rate items that have to be stocked. Where we do fall short is there might be hubs of logistics centers up in remote places in Alaska that we could utilize as a logistics node or a point, and or do we have the right stuff at the right time in those locations? We really don't have good visibility, or are there other vessels out there that have those same parts we might need? So, as we build a polar security cutter, we could be sending more like fleets of cutters instead of one cutter up there. So I do see a significant role logistics and data could play in better supporting those missions in an austere environment.
And to play off that point, I'll float it to the whole panel. Do you think the U.S. is sufficiently worried about poisoned or tampered stockpile data? Like you said, you imagine sometimes the first shot will be physical, maybe, or kinetic, excuse me, maybe it won't be. How do you deal with potentially compromised stockpile numbers? How do you identify them? How are you thinking through that? So on. General Upton, I don't know if you have thoughts.
I think it's a vulnerability, but I would say in that data space in cyber and the log world, because so much of our systems even operate on a non-classified environment, we're in a competition space every minute. Right. There's large strategic force projection entities in the DoD that they're being attacked constantly just for their data. I think the way we've got to look at that is we've got to look at the technologists in here, this data discussion and technology maturation of there's going to be some stuff worldwide, globally. When you talk an environment of contestation where you're going to have to compute some things, that they're going to have to compute at that point of need or where that thing, and keep computing, but they may be denied access or denied constant communications. We're already working on that in the Army, and so is the Joint Force, on how you basically cannot connect or disconnected, they call it disconnected ops, disconnect compute. So much of our logistics and sustainment is transactional. We've got to make sure that we see the demand very rapidly and then act on that demand, quite frankly, all the way back here to the strategic support infrastructure in the United States. And then that's back to the visibility piece. If you're going to protect that data, then how are you sharing it? I'd say there's probably some folks out there, especially in the defense industries, like government's not real good at sharing data. That's a two-way street, but it's how when you say open, absolutely. We absolutely have to go there. But then it's how then we constantly, that you almost bring in that concept of layered protection we think of that as a formation base or a human thing, you also then have to look at your data and how you layer protect that. And there are absolutely companies in this space and in this room that can help us figure that out. I would say that would be my final point, but we have got to look at that. Because I think there's just as much threat risk as spoofing data, and we make a bad sustainment decision, and in a positioning fight like Indo-PACOM, a bad decision is we may not recover from that, meaning that asset or that troop formation may not get what they needed to do because of that data-driven decision that was spoofed.
And when you and I spoke earlier before this panel, you mentioned always playing the away game. Could you elaborate on that? And then I think, Andy, you'll have a good bit to add afterward.
Okay.
I will tell you, and just the previous fireside chat talked about Freedom's Forge, but the sanctuary that we had as a nation in that war, that is gone. One, in the pervasive nature of, PLEO, low Earth orbit satellite observation, and then anything that's even, down in the systems that are terrestrial on land, sea, and air. We're constantly observed. I will tell you, we're going to have to play away game, but we have to be ready then to force project out of our homeland in a different manner. I would offer, I'm optimistic that we're going to figure this out, but we have got to figure out how to force project when somebody is trying to deny either cyber or kinetically or non-kinetically every major port, potentially major hubs where we force project forces from our services out of, and how do we protect that? So, I turn it over to my teammates here, but that's what we have got to look at when we kind of say that home versus away game. I want to play the away game. I think in the logistics space, we're going to play it from the entire spectrum, from home to the point of impact.
Andy, I guess the follow-up question for you is, how do you get something like a LEO into the theater, into where the fighting's actually happen? Because you are playing that away game, as General Upton said.
Well, it's wide bodies, C-17s, that sort of thing, or ships. Again, they need to be mobile. They need to be robotic. Almost everything we build new for the DoD should have an option to be very low human touch needed. A little bit, but like I said earlier, but not a lot. The space point that you made is a very interesting one. I'm not going to answer how you thought I was going to answer. I'm going to fly up into outer space for a second. I was talking to some folks that have a company they're building around space domain awareness. Because what they told me was that, when a war starts, it's like like the initial position of a football match or something. Everything switches then. They all start running around and doing everything like that. And so, I think that the next war will be lost and won by how we do in space. I really do. I think space is going to be a major place where we find a contested battlefield, if you will. So when you talk about that, there are plenty of companies, plenty of the smaller space companies nowadays that are putting together these hunter-seekers. Now you couple that with directed energy. Imagine this. I have a directed energy system, microwave, whatnot, on one of these hunter-seekers. They get in close to some satellites, boop, they're down on the ground. They don't know what broke in their satellite. They don't even know what hit them. So there's things like that that I think we can be clever about as we implement these new technologies. I think there's room in space for this type of tech that we've invented here at Epirus. There's room on the ground. There's room on the surface. As you said earlier, we're working with the Coast Guard, actually, right now to put a system on one of the Coast Guard cutters to do kind of outboard motor interdiction. Because, again, this thing is anything electronics in it, it's going to take down, if it's in a significant or in a close enough way. So I think, the way to do it is, again, protect our lines, strategize with a lot of these attritable targets that we're talking about. I'm a big Star Wars fan, so let me do a Star Wars analogy. We got millions of clones, running, just throwing them at each other, and the Chinese are throwing their clones at us. Those are, no offense, Andrew, but you guys are making the clones, in my analogy. And then I'll be making the Jedis. And the Jedis, if you watch any of those, are the ones that kind of protected. They were a little more sophisticated, a little bit harder to come by, but you had a few of them, and they would do that protection. I think strategies like in that science fiction show like that, where they would have a balance between these clone warriors and these Jedis, needs to be how we think about it. We need to think about Some not totally exquisite machines, but some machines that are exquisite enough to do some of these really, really high-tech things that I know that China is 5, maybe more years behind us on when it comes to active electronically scanned arrays, and AESAs and phased arrays they're called as well. These types of things we have a huge advantage of over China. So we need to leverage our advantages. We can't play the away game. We can't be a me too to China. There's no way we're going to outbeat what they've got in Chongqing and all these other different factories. It just will never happen. So we have to be clever about it. That's my point. We have to be clever. And I think with the right mix of different technologies, old and new, and I'm not throwing my old brothers at Raytheon under the bus, there's still plenty of good stuff that Raytheon and others can do with this. But I think old and new, we need to find a new strategy. Come together as government, education, and industry and build a new strategy. And I think General Rainey is doing a lot of that. I mean, invited me down in Austin on April 1st. I mean, there's a lot of work being done as far as re-strategizing from the ground up how we fight the war of the future.
You got the last word, Mr. Lowery. We're out of time. Red zeros across the board. Thank you guys for your remarks, and thank you guys for your attention.
Thank you.